why,
Sorry about that.
yeah, so why introduce these things into my teaching? The main reason is motivation. I'm sure we have all had students, who are simply naturally interested in math and love to learn. But we also have a lot of students who aren't naturally inclined to enjoy math classes, and we want to keep them engaged, show them that math can be useful and also that math can be fun. Um, and these activities, they appeal to learners with different learning styles. Uh, oh, sorry, did not mean to click ahead yet, but so let me go. Uh, I'll just skip that for the moment. A little bit about me. I've always loved puzzles and games. I actually taught ballroom dance as an undergraduate. That's how I helped pay my way through undergraduate. You can see this is my family. I'm actually expecting my first grandchild in about 3 weeks. Um, so that's exciting. And then the canine members of our family. But as far as how I learned mathematics, I learned in a traditional lecture classroom. And that's how I taught originally as well, because it was what I was familiar with. And it was through attending conferences like AMATYC, like Math Fest and the joint meetings, that I started learning about active teaching. And that started about 18 years ago, and it's been a journey, and I'm still learning and figuring out better ways to do things. Something I didn't include on this slide, but actually this fall I will be on a sabbatical, and I'm going to make a shameless outreach call here. My sabbatical is going to be both creating and collecting active learning lessons, starting from intermediate algebra through the calculus sequence, um, discrete math, anything like that. If you have activities that you would like to share, to my knowledge, nobody has created a database of those activities and indexed them well, and that's what I'm going to be doing. So if you have things that you would like to share, please feel free to reach out to me and forward them, and they will be included in the database. So games and puzzles, I'll start with those. I use these in courses starting with developmental math, which, we start at arithmetic and move on, all the way up to discrete math, which is our introduction to proof course. And these games and puzzles can teach important lessons, different lessons in different levels of courses, while also making the math more fun and more engaging. And I'm going to give you an opportunity to try a few of these here. So we're going to start out with one called nonograms. They're also called gridlers. They're also called paint by numbers or Japanese Sudoku. They go by a lot of names. And they don't require any mathematics beyond arithmetic as far as background. And yet they can be used in multiple levels of courses. And depending on the difficulty of the gridler that you choose, it can be challenging for upper level math students, or it can be relatively easy for those developmental students. So here's how a gridler works, right? You have a rectangular grid, sometimes square, sometimes not. And on each row, there is either a single number or a series of numbers. If there is a single number, like 7, it means that 7 of these cells in a row should be colored in, right? and the other three should be left blank. But which seven in a row, we don't know. So that could start in the first cell and go to the seventh. It could start in the second cell and go to the eighth. It could start in the third cell and go to the ninth, or it could start in the fourth cell and go to the 10th. Any of those are possible, but it does have to be seven in a row. They have to be continuous. When there are two numbers, such as 5 and then 1, there has to be, again, a group of 5 cells in a row that are colored in, then at least one blank space, and then another single cell that is colored in. There can be blank spaces before or after the group of 5 and the singleton. There can be more than one blank space between them, but there has to be at least one. Right? And then the same thing is true with the columns. So I am going to see if I can put in the chat a version of this that you can actually open up. Let me see if it'll let me upload a file. All right, so that is now in the chat as a PDF if you want to download this and try it for yourself. I'm going to give you a few minutes here. I don't expect that you're going to finish the whole thing in a few minutes if you haven't done these before. But
it didn't, I don't think it went through.
Oh, let's try again. Are you seeing it now?
Yes.
Okay. If anyone would like some hints to help get them started, you can ask me in the chat and I'll send that to you rather than to the whole group, because I know some people want to do this all on their own. So there's a question in the chat about how I would use this in class. It does vary from class to class whether this is a warm-up activity, something that I would send them home with after explaining the rules in class. A lot of the lesson in this is about logical deductions, about making conjectures and then testing those conjectures, and then possibly backtracking if that guess is wrong. So there are a number of ways that this can be connected to other math topics. All right, so one of the things, I guess I will say this to the general group, it's easiest to start in lines or rows that have either large numbers or numbers that add up to large numbers. that we can use logic to figure out how to color in at least a couple of the squares or cells. And once you have some colored in, then that gives you a clue for the next step. And again, I tie this to problem solving of taking a big problem and saying, okay, what part of this problem is within my reach right now? What can I tackle right away? And then once I've done that little piece of it, does that give me a clue for something else that I can do? So it's a good metaphor for problem solving in general and helping students to prepare for more advanced projects where they may not know how to start out yet and saying, look at one piece that you think you can handle and start with that. And yes, I am very much looking forward to being a grandmother. All right. So can I see some reactions here of how many people have been able to get at least a number of the cells colored in? So again, once you figure out a few of them, then you should be able to use those few to help with a few more. And it's often working back and forth between the rows and the columns. Uh, so again, this idea of maybe you get a little piece of it, now try tackling it from a different angle. In this case, literally a different angle, vertical versus horizontal. Give this about another minute here, and then we'll go ahead and look at a solution to this and how we get there, not just the final solution. So before I move on to the solution, this QR code will take you to a website that is free where you can get Gridlers at any level of difficulty. And again, they're called by a number of names. And you can get printable versions if you want to do this as an in-class activity, or you can direct students to the website. One warning, these QR codes will expire in 10 days, so make sure you open it and save the website for yourself if you want to use this. Right. And again, I will, if there's a place I can share these slides after the talk today, I will share those. So if you didn't get this yet, those should be available from AMATYC. I'll talk with Kim or somebody about where I share those. Okay. So again, good strategies and ones that students often discover for themselves is to start with rows or columns that have large numbers. So in this case, Let's start at the very top row. While the three blank spaces can be either all before or all after the seven that are colored or split in between them, the four cells right in the center of that row have to be colored in. Right? Now, we don't know about the three on either side yet, and that's okay. Right? We can do the same with the third row, which also has seven. With the second row where there are six, it's only the two in the middle that we can color in. But we can also start looking at the columns. So these four columns where the top cell is colored, we know then that in this column here with the seven, the first seven are colored and the last three are blank. Same for the fifth column, same for the sixth column. For column seven, the top three are colored and the fourth one has to be blank. And again, part of this, I use it as an exercise in having students communicate their thinking about something mathematical, and logic is part of math. So when students do this correctly, I'll ask them to explain. I'll have student volunteers come up in front of the class, or I'll have them write a little bit about how do we know what we know. Because that's a huge part of mathematics and a huge part of being able to use math in real life. Right. So just using this strategy, we can fill in quite a bit. So again, the second row, the third row, we can fill those in. And then these three columns, and I forgot to fill in this one here, but that should be filled in as well. Uh, column three, where there are six, I can fill that in. Now, in rows with more than one number, remember that there has to be at least one space between each group. Here, I've got four cells in a row that are colored. So that's the four, and that has to be to the left of the one. So these two cells, and again in the sixth row, these four cells here have to be blank, and the two cells right here that I'm pointing to have to be blank as well. We often fill those in with X's or at least with dots to make sure that we remember as we continue working on the puzzles which ones we know are blank. Now, how did I know to put one here? Because these three are going to be colored again. Sorry, I didn't get that to show up on the slide. But that means that this fourth cell in this column is blank, which means the five have to go this way because that's got to be a blank right here. And you can see I'm starting to fill in some X's in things that I know must be blank. How did I know that has to be blank? Because those are four cells. There can be a fifth one here, but it can't go here. That would make six. All right. And again, I'm taking some big leaps here because we have limited time. But this is the finished puzzle. Now, that doesn't look like a whole lot. Um, the simplest ones, the pictures are pretty elementary, but I want to show you what you can do with these with more advanced ones. Right? These can be beautiful. So you've got your dragon here, your sphinx here. Right? So these can turn into some gorgeous pictures. Um, these are also available in color versions, but actually the two color, just black and white, or just any two colors, are the easiest to explain and to extrapolate these concepts that we want students to get out of the puzzle. So some of those concepts taught, again, to reiterate, start with low-hanging fruit. Go for what's easiest first. This is a good problem-solving strategy for students to use in lots of mathematical settings. Right? The fact that it's okay not to fully solve a piece of it at first, to only have some of the answer, and know that you're going to have to come back and work on it some more. Again, students are often used to being a bit spoon-fed in mathematics and given problems where they can solve it all at once. And here they have to learn a little bit of patience and that I might have to come back to something. The fact that each little piece you figure out gives you further clues to help solve other pieces. And again, as you get to more difficult versions of this, educated trial and error. So putting a question mark in a cell that might be colored, that could be according to the rules of logic, but you're not sure. And then seeing if this is true, what does it lead to? Does it lead to a contradiction? If so, then I backtrack and I know that cell is blank. If it leads to a solution, great, I've got my solution. Uh, so again, those are good strategies for students to learn. Keeping track of negative inferences as well as positive ones is a good thing for students to learn as well. And then communications, having students be able to explain their thought process, working on communication in math about math is an important skill. Um, I'm not going to do this second one with you in the interest of time, but if you want to take a screenshot of that and give it a try, you are welcome to do so. Right. This one obviously is a little bit more challenging in that it's a slightly larger grid and you have rows with more than two numbers in them. So again, keep in mind, these have to be in order. 5 cells in a continuous row, then at least one blank, then one, then at least one blank, then 5 in a row, then at least one blank, then one. So again, if you'd like to try this on your own, I'll let you grab a screenshot. I'm sorry I didn't have an upload for that one. And that brings me to another type of puzzle. Used to be called cross numbers, and these have been around since at least the 1970s. But they became popular in Japan and were named keikoru. So I'm just checking the chat here. Right. So the idea here, the numbers that are in the upper triangle, where each of these is divided in two, tell you that the digits entered in the white cells next to it have to add up to 4. The ones in the lower triangle tell you that the white cells directly below it have to add up, in this case, to 6. The catch is you may only use digits 1 through 9 in filling in the white cells. And you cannot use the same digit more than once in the same block of numbers. So where there's a 4 here, it can't be 2 and 2. So in some order, it has to be either 3 and 1 or 1 and 3, because you're not allowed to repeat the same digit. Now, again, in terms of skills, background skills, students can start this knowing just arithmetic. But they have to do a little bit of thinking to say, how can I break seven up, for example, as a sum of three digits with all of them being different? And figure out that in that case, there is only one possibility that there has to be a one, a two, and a four, and if we're not allowed to repeat. Now we know this four has to be a three and a one. We can't put the three here because there's no three in the way we break up seven. So that would have to be a one. That's going to have to be a three. And again, the idea is starting with low hanging fruit and using inferences from what we've already figured out to help us figure out more pieces of this. So it also reinforces some of those same skills as the previous one. And again, this will expire in 10 days, but this will take you to a website where you can get Keikoru puzzles ranging from very simple to some pretty complex ones. And again, I'm sorry, I'm not letting you sit there and play with this one during the talk today, but limits of time.
You may not have seen this, but somebody asked about how long you let your students do these in class and if you let them work in groups. I thought that was good.
So if I'm doing this as an in-class activity for these entry-level ones, I give about 5 to 10 minutes. And yes, I do typically have them work in groups and talk it through as a group. With the caveat, and I do this with all my group work, so you know how sometimes you get that one strong student who just solves the whole problem by themselves. So when we go to present solutions, I say, I will call on any member of your group to come and present. So if you are the one who is solving this, make sure the other members of your group understand your reasoning. So again, that communication piece and making sure that students are interacting and not just here, I'm going to take that and fill it out and nobody else does anything. Yeah, and there are tons of similar games. I see some suggestions in the chat. Yeah, there's a lot of these that can be used to help develop reasoning and the idea of how to tackle problems and process of elimination and educated trial and error and backtracking. Those are all huge lessons. Some others that I use, and again, I won't have time to do all of these here today. Set game. For those of you who are not familiar with set game, and I know some of you are very familiar with it, you have to make sets from a special deck of cards where all three cards in a set either share a trait in common or have all three different on that trait, and there are four traits. And I'll show you one quick example of that. Tower of Hanoi, there's online versions and there's physical versions of this puzzle. That's the one with the three poles and a bunch of graduated discs on it. And that can be used to introduce the idea of recursion and induction in a discrete math class or a survey of math class. Um, okay, all of these look very different. Spin out, the brain, and the Chinese rings. And again, there's physical versions and online versions, but they are all actually the same concept, even though physically they look completely different from each other. And again, those are excellent if you're teaching about recursion. This gives you a recursive pattern that differs for odd numbers versus even numbers. So that's a nice little twist to it. Sudoku, again, very popular, and many, many more. And this will take you to an online free version of Set Game. The actual Set Game website has not been functioning for a while, but several people have made their own versions. So if you want to try that out or use it with your students. And by the way, I use Set Game as an icebreaker on the first day of class. I introduce them to how you make sets, and then I give the students a very carefully crafted collection of set cards, one card per student, and they have to find out which students they make a set with, and then introduce themselves, find out names, something about the other student. So it's a good way to get people to talk to each other. Right? And then we come back to that. It's good for learning counting techniques, some other things like that. Now, music and dance in mathematics. So going back to developmental math, one of the skills that students often struggle with, and this haunts them as they go through the algebra sequence, is addition and subtraction with signed integers and signed numbers in general. And of course, that then leads to problems with multiplying and dividing with signed numbers. So I created a physical activity that you can do in a face-to-face classroom, but also an interactive online activity for if you're teaching in a remote or online class. So the physical version, I created and had laminated a large life-size number line that I lay out on the floor, large enough that you can step from one number to the next without it being awkward. And then I put a large plus sign on the wall on the positive side of the number line and a large subtraction sign on the wall or negative sign on the wall on the negative side. Then to learn about addition and subtraction with integers, we have students walk or dance that number line. So the way this works, students start at 0. They walk to the first number in the addition or subtraction problem. And then depending what this sign is here, they either face the addition sign or the subtraction sign, whichever is indicated. Right? They then walk or dance this many steps forward if it's a positive number, but backwards if it's a negative number. Right? So in dance, there are forward movements, but also backward movements. So it's normal in dance that you would have to be able to move both ways and don't always just go forward. Okay? And again, I set this up as an activity where students are doing this in the classroom, alternating who gets to be the dancer. In bigger classes, I'll have several sets of these number lines laid out so multiple students can work on it at once. Right. And again, it works for extended problems. So they would walk to 9, they would face the plus sign, they would walk backwards 12 steps or dance backwards 12 steps, turn and face the subtraction sign, dance backwards 4 steps, turn and face the addition sign, and walk forward 2 steps. And of course, whatever number they land on is the final answer to the problem. Right? And this helps them to understand, in particular, why subtracting a negative number is the same as adding a positive number, because if I'm facing the opposite way and walking backwards, that's the same thing as if I were facing the positive direction and walking forwards. And as someone who taught ballroom dance while I was an undergraduate, I'll sometimes bring that in, that in ballroom dance, you dance with a partner and you're facing towards each other. So when one person is facing the subtraction sign walking backwards, their partner is facing the addition sign and walking forwards. Now, this may seem very elementary, it's only for developmental classes, but I then extend that. So this is just what I said. Again, I'll upload the slides if you want that in writing. Um, I'll extend that to polar coordinates, and I'll show you that in a minute, but let's talk about an online version for this. So you would use your preferred software to create number lines, labeled number lines at the appropriate lengths, with large plus and minus signs at the appropriate ends. Right? And then you can use figures of people, or if you prefer, you can do cars, you can do animals as the markers, just as long as whatever figure you're using is clearly facing either left or right. And then you make a duplicate that faces the opposite direction. So this is an example that I created in my preferred software. Whoops. I'm trying to go back. Right. So we would place the dancer with that little marker on the number line facing the appropriate way, move the correct number of steps, and then if we're going to do addition, we can keep facing forward. If we're going to do subtraction, we switch out the images there. So, and the version that I've created for this in the classroom software I use is something that the students can manipulate on their own screens on their computers. And again, there's lots of software that will do this. I use Smart Notebook as mine, but whatever you normally would use for that. I mentioned the ballroom couples, so using the image of the couple can help them to see, right, that adding a negative is the same thing as subtracting a positive, and right, adding a positive is the same as subtracting a negative, looking at which way the two figures in the couple move. But a more advanced version. Have your students learned, if you're teaching a trigonometry course or a pre-calculus course, they're learning about polar coordinates. So again, in a classroom, if I have space, and sometimes I'll reserve a special room for this if our class doesn't have the room, I will lay out a life-size polar grid on the floor, um, with the angles in standard position, either in radians or degrees or both, whichever we're working in at the moment. Right? And then students would start out at the center, at the pole. And with polar coordinates, they would face the direction of the angle. Remember, we give polar coordinates as r comma theta, where theta is the angle in standard position and r is the distance or radius. Right. So if we had, say, 5 comma pi over 3, they would stand at the pole, face pi over 3, and walk or dance forward 1, 2, 3, 4, 5 steps. But if you have negative 5 comma pi over 3, you would still face the pi over 3 sign, but go backwards 5 steps. Right? And I give them this activity, and then I ask them to use it to find an equivalent expression for that same point in the plane to realize that if they faced 4 pi over 3 and went forward 5 steps, they'd end up at the same spot. And again, I introduced this idea of the couple that are dancing together. So if I'm giving directions to the two members of the couple, I have to have them facing opposite ways. So one has to face pi over 3, the other has to face 4 pi over 3, right? And then one is walking forward while the other walks backwards. And again, you can see here a virtual version of this that in the software I'm using with them, they can play with on their own. But in real life, I like them to get up out of their seats and actually walk this out on the floor. Uh, Questions? So I had to have my school create this life-size grid for me. So we were able to get a large square mat and then print it. Um, you could do it with a large blank sheet and draw it on a sheet, maybe a king size sheet or queen size. Other questions? Okay.
I don't.
Now to music. So again, a concept that students often struggle with at the developmental level. I know we also cover this in our survey of math, which is our liberal arts math course. Um, so least common multiple and greatest common divisor. A way to teach that with music starts with assigning roles. Right. So you're going to choose 2 students for each time you do this who are going to clap, or they can tap on their laps, or if you have instruments you want to bring in, they can, tap a drum or ring a cymbal, whatever you like to bring this to life. And the first student is going to clap on every nth beat, so maybe every fourth beat. And another student is going to clap on every nth beat, say every third beat. And again, if you have instruments, great, that makes this even better. Right. And then,
Miriam, sorry,
yes,
just a heads up that we've got the next presentation will be beginning at 9:50. So just
okay, so I should finish up.
yes.
So let me finish with this. So other students are going to count aloud along with the beat. Right. And then you're going to assign several of the students to mark down which beats the students make their sounds. Right. So I give them a grid, something like this, whether it's virtual or in person. Right. And the LCM is going to be the first number where both N and M make their sound together. And the greatest common divisor is going to be the smallest positive difference between a mark in the N row and a mark in the M row. And I'll let you think about why that is, but it's a fun way to bring something active and musical instead of just a boring old lecture. It's just more memorable. It uses auditory and visual signals. So you're using different pathways to the brain. You can do the same thing with string art. If you remember that from your childhoods, those of you who are around my age or older probably remember this. The same lesson that we just did with music, and you can do this individually or in groups. Designate one of the nails as 0. You're going to take one color of string and attach it to every nth nail around the circle, and a different color, attach it to every nth nail around the circle. It's the same lesson, but this time visual and tactile. Um, and I guess I will finish with that. Um, so sorry I didn't get to the symmetry part, but that's my talk for today. And any questions? We have about 5 minutes, 4 minutes. I'll be happy to answer.